levels of structure here. Here's the whole darn kidney with the renal, pelvis, major calyx, minor calyx, the pyramids. So we've got the renal, yeah, come on over here. Renal medulla that contains the pyramids, and then the renal cortex out here. And then the gaps between the pyramids are the renal columns. So that's kind of the big picture, and it shows the nephrons in white here. But here we're zeroing in on an individual medullary pyramid with the cortex. And then the nephron is superimposed on top of it here. Now the interesting thing about the nephron is the renal corpuscle, Bowman's capsule, and the glomerulus are in the renal cortex. But the medulla is where the loop of Henle drops down in here. And you can see they are of varying lengths, and I mentioned this briefly the other day. You can actually tell the habitat the critter lives in based on how long the loops of Henle and that kind of thing are. And then we've got the collecting duct that the nephrons feed into. The collecting duct goes down to the papilla and drip, drip, drip the urine into the minor calyx and the renal pelvis, ureter, bladder. We're out of there. Now, this part of the model is a blow-up of the renal corpuscle. So we've got Bowman's capsule. All right. And then we've got an afferent arteriole entering it and forming this tangle of capillaries, the glomerulus, that then collects back together and comes out as the efferent arteriole. And this half of the model shows the podocytes, but the other half, the podocytes are stripped off. And you can see how the podocytes interdigitate and form the filter. Because recall what we're doing here, we're filtering blood plasma. So we've got a blood supply coming in, relatively high pressure, and then the filtrate oozing out between those fingery gaps of the podocytes that then on down into the loop of Henle. So first, of course, we've got the proximal convoluted tubule, the one closest to the corpuscle. And this model doesn't show it, but we've also got the distal convoluted tubule, and a segment of that is right here. Remember, I was wrapping up with the juxtaglomerular apparatus. So this is a segment of the distal convoluted tubule, and you can see that the cells get funny here. We've got some columnar cells that are bumped up against the afferent arteriole with its little bits of smooth muscle, so that the distal convoluted tubule can talk to that afferent arteriole and regulate the amount of blood entering the corpuscle so that we can control the filtration rate here. So that if we're producing too much urine, if the urine is too dilute, if we're losing too much water, in other words, that will signal this smooth muscle to contract and reduce the blood flow into the corpuscle, which will reduce the filtration rate.